Sources of energy. Energy sources can be classified into renewable energy sources and non-renewable energy source. The characteristics of renewable energy sources are: first, unlimited amount. Second, they can be regenerated by the nature. Also, low greenhouse gases produced. The examples of renewable energy sources are wind energy, hydroelectric energy, solar energy, and geothermal energy. And the characteristics of non-renewable energy sources are: they are limited amount. They are used up at a faster rate than being made. Also, they cause greenhouse effects. The examples of non-renewable energy sources are fossil fuel and nuclear energy. Solar energy. What is solar constant? Solar constant is defined as the total electromagnetic radiation energy radiated at normal incidence by the Sun per unit time per unit area at the mean distance between the Earth and the Sun, measured on the outer surface of the Earth's atmosphere. Note that solar constant equal to 1366 watts per meter square, and it is measured by using satellites. Since the atmosphere will also absorb solar radiation, the solar power per unit area on the Earth's surface will be smaller than 1366 watts per meter square. Example 1. Part A. The mean distance between the Earth and the Sun, R, equal to 1.5 times 10 to the power 11 meter. Hence, we have the total power emitted by the Sun equal to solar constant 1366 times 4 pi r square, which is equal to 1366 times 4 pi times 1.5 times 10 to the power 11 the square, which is equal to 3.86 times 10 to the power 26 watts. For part B, for the Earth, the cross section of the Earth has an area A equal to pi r square, where r is the radius of the Earth. the sunlight falls perpendicular to the cross-section. Therefore, the total solar power reaching the Earth will be equal to 1366 times pi r square, equal to 1366 times pi times 6.4 times 10 to the power 6 square. Answer is 1.76 times 10 to the power 17 watt. Example 2. Let's assume that the solar power or the sunlight incidence normally on the solar panel. Then the solar power received by the solar panel equal to 1000 watt per meter square times the area 10, which is equal to 10 to the power 4 watts. Since the efficiency of the heater is 50%, therefore the power generated as heat equal to 0.5 times 10 to the power 4, which is equal to 5 times 10 to the power 3 watts. And the rate of heat absorbed by the water is equal to mc delta T over time T, which is equal to (20 times 10 to the power -3 kilogram per second times 4200 times delta T. And this heat absorbed, the power equal to the power produced by the solar, which is equal to 5 times 10 to the power 3. Therefore, delta T equal to 59.5 degrees Celsius, implying the increase in water temperature equal to 59.5 degrees Celsius. Solar cell. The main components of a solar cell are: first, an anti-reflective coating printed at the top. Second, a N-type semiconductor, usually made of silicon. Third, there is a P-type semiconductor, generally making of silicons also. Anti-reflective coating, N-type semiconductor, and P-type semiconductor. How does a solar cell works? First, when the N-type and the P-type semiconductors are joined together as shown, some electrons in the N-type semiconductor move across the P-N junctions to the P-type semiconductor. At the same time, some holes, or we say positive charges, in the P-type semiconductors will move to the N-type conductor. Hence, an electric field is set up which prevent further flow of electrons. Also, a voltage is built up in the solar cell. When light falls into the solar cell, the light energy is absorbed by the cell. This produces one free electrons and one hole. And due to the electric field, the free electrons will float to the N-type semiconductor, and the holes will float to the P-type semiconductor. If an external load, for example, a light bulb, is connected to the cell, the free electrons in the solar cell will flow through the path to the P-type semiconductor to recombine with the hole. The flow of electrons will produce a current. Why the efficiency of a solar cell is too low? Because not all the light energy is absorbed by the solar panel, and not all the light falling on it will produce free electrons. What is the use of the anti-reflective coating? The anti-reflective coating is used to reduce the reflection of light so as to increase the efficiency or increase the current of the solar cell. Why does a solar cell look dark in color? Due to the anti-reflective coating. Only a small amount of light is reflected, so the solar cell looks dark in color. Note that solar cells produce direct current or DC voltage. It is changed to AC before use by the domestics by using inverter. When solar cells are connected in series, the total voltage increases. When solar cells are connected in parallel, the total current increases. The solar cells converts solar energy into electrical energy. The advantage of using solar cell is renewable energy. It is environmental and unlimited supply. The disadvantage of using solar cell or solar energy is low end-use energy efficiency, and the cost of large solar panels is high, and conversion from DC to AC is needed. The energy has to be stored for lifetime use. For a solar cell, the voltage is very small. When a number of solar cells are connected to each other and mounted in a frame called a photovoltaic module, the modules are designed to supply electricity at a certain voltage, such as 12 volts. The current produced by the module is directly proportional to the amount of light incident on the module. Multiple modules are wired together to form an array. The more the number of modules of an array, the more solar power will be produced. They can be connected in series or parallel in order to produce different combinations of voltage and current. Example 3. Since the solar power is 1000 watts per meter square for normal incidence, in this case, we have the solar power P equal to 1000 times sine 30 degree, which is equal to 500 watts per meter square only. Therefore, the solar power on the panel or on the modules is equal to 500 times the area of the module 20, which is equal to 10 to the power 4 watts. Part A. Since the efficiency of the solar panel is 25%, therefore the output electrical power of the solar panel will be equal to 10 to the power 4 times 0.25, which is equal to 2.5 times 10 to the power 3 watts. The energy, electrical energy produced by one module in 8 hours equal to 2.5 times 10 to the power 3 times 8 times 3600 seconds, which is equal to 7.2 times 10 to the power 7 joules. Therefore, the minimum number of solar panels N is equal to 3 times 10 to the power 15 over 7.2 times 10 to the power 7 equal to 4.17 times 10 to the power 7